This video is an introduction to the CCP4 Graphical User Interface CCP4i2. We begin by double-clicking the CCP4i2 icon to launch the program. The first time you launch the program, you'll be presented with the following screen, with links to documentation on the CCP4i2 program. The first thing we do is create a project to do our work. We do this from the Projects, New Project option. In the next dialog, we type in a name for the project. I'm going to call this one Video Demo. We could here type a description of the project to assist with our project management. We skip this time and just click the Create Project button. We are now presented with a project window. The left-hand side of the project window gives a list of the jobs in the project. At present there are none. The right-hand side of the project window is currently showing the list of tasks available in CCP4i2. We are going to run a refinement job as an example of CCP4i2. We select a refinement job from the refinement section of the task interface. We click on the refinement with RefMac 5 and click New Job. The left-hand side of the project window now shows a new RefMac job, labelled Pending, that is, not yet run. The right-hand side of the project window is now the input to the RefMac job. The input is broken down into various sections: input data, parameterization, restraints, output, and advanced. We're going to ignore everything but the input data in this demonstration. There are various options in the input: atomic model, reflections, free R, phases, restraints. Data which is highlighted in red is data that must be provided but has not yet been given. A refinement job requires two sets of data: an atomic model and a set of observations. CCP4 comes with many sets of example data, and we are going to use one of those. To do this, we used the Utilities Copy Demo Data to Project option. We are going to use the RNA's data. This tells us where the test data was copied, and we simply click OK. The input entries usually contain a list of the data that has been used in the project. As this is our first job, these are currently empty. So we use the File Browse icon here to load in the data we just imported into the project. The file browser does not come up in our project directory, but we can make it go there by looking in the correct CCP4 project. Video Demo. The RNA example data we copied is in the RNA's subdirectory. From here, we load a model. In this dialog, we can, as with the project, give a description for project management purposes. The reflections line is still red, so we must provide a set of observations. We browse in the same place and select a set of data. An MTZ file may contain multiple sets of data, either intensities or amplitudes. So CCP4i2 presents us with a dialog where we can select the data we want. By default, the program picks the richest set of data, in this case anomalous Fs. We just click Apply. Finally, we give a set of 3R reflections in the same way. In this case, we use the same file. The task is now ready to run, so we click the Run button. In the job list, the job is now labelled as running with the start time. We see a running man above the task interface over here. As soon as the results are available, they are presented in a new results window. The key data for the calculation are shown in a table and a graph. The job is now finished. A green tick appears in the job list. Had the job failed, this would be a red cross. We get the finish time and the key performance indicators for this job. The report now contains much more information. One can look at information per cycle. Various tabs in the report can be opened and closed. Here we have a picture. There is also some analysis output and a Ramachandran plot. What is presented in the report depends on the job that has been run and its particular options. We can also see a list of the input and output data for this job. If we right-click on any of the icons, we get a list of options such as viewing the data. We can also look at the bibliography for the programs that have been used in this particular job. And we can, if we wish, click on this button to export a traditional MTZ file for use with other programs. To continue with our project, we wish to run more jobs. We could do this from the task menu and select a new task to run. Alternatively, at the bottom of the jobs report is a list of suggested tasks. We will use Coot for manual model building. We click on the Coot button here. A new job is created in our job list. The input panel that now appears has a Use Data from Job option. In this case, this is set to job 1. Typically, our project will contain many jobs, and we can use different data from different jobs. All the other input options are now automatically populated from this selection. We just click the Run button. There are lists of suggested fixes or areas of interest from the multiprobability analysis in the refinement job. We can also use Coot's own validations validation and analysis tools. And we can see here that there is one large area of interest or concern. We can attempt to fix this region with the Real Space Refine Zone option in Qt. There may be, of course, further work to do in Qt, but we skip this for now. Rather than just saving a file as we would normally do with Qt, we do File, Save Mol to CCP4i2. Our edited model appears as output data for this Qt job. Additional help on CCP4i2 can be found from the Help menu, which gives a list of tutorials and various information about tasks. When one clicks on a job in the job list, the Help button in the toolbar brings up detailed documentation about the task interface. You can also find information about tasks from the Task menu. Hovering to the right-hand side and clicking the question mark will bring up the documentation on that task.